Time to prepare for the law of cosines. First question that you're going to see tomorrow, what is the law of cosines? You can use any one of the formulas that we started with. I'm going to say a squared equals b squared plus c squared minus 2bc cosine of a. That's the standard form. You can also use the alternative form, which would be something like cosine of a equals b squared plus c squared minus a squared all over 2bc. Either one of those is absolutely fine. For what triangle setups does it work? We said it works for side, 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 and for side, angle, side, and that is it. How do you know if the triangle does not exist? When you're solving, you would end up getting cosine of theta is bigger than 1. That's your issue. Or if you can say that you saw that the sum of two sides of a triangle is less than the third side. That's when the triangle just didn't exist. And you'll see that later on in this review. I think it was number 9 on this one where the triangle couldn't exist. So the sum of 2 is less than the sum of less than the third one. How's the Pythagorean theorem a special case? Well, if we just set up, I'm just going to do it like this because this is the way we mostly see it, is a squared plus b squared equals c squared. We want to start with the law of cosine. So we want to have the 1 to begin with. Like, I'm step ahead of myself. Cosine c. In the Pythagorean theorem, we need to have c as a 90-degree angle. So I'm just going to write it that same way. C squared equals a squared plus b squared minus 2ab cosine of 90 now. Well, cosine of 90 just is 0. So that means that the entire term goes to 0. And all I'm left with is c squared equals a squared plus b squared, which is the Pythagorean theorem. So all you need to say is pretty much show the relationship that you have here with the Pythagorean, and just that cosine of 90 is equal to 0. Alright, 2, the problems themselves. First one we'll look at, number 5, triangle COS, and don't worry, I said that we're going to have triangles A and BC always tomorrow. But what we need to look for here is I need to find side C first, because angle C is all I have. So, I'm going to say C squared is equal to, we're going to have O squared plus S squared minus 2OS cosine of big C. Plug and chug, C squared equals, O is 51, S 64, minus 2 times 51 times 64 times cosine of 25 degrees. From there, just plug it into your calculator. You should get 780.62. Take the square root of both sides, and I get C equals 27.94. So C is 27.94. Next step then is to try to find one of the angles. Well, I now have something I can set up with the law of sine. So, sine of 25 degrees over 27.94 is going to equal sine of big O over little o, which is 51. Cross multiply, 51 sine of 25 is equal to 27.94 sine of big O. Divide both sides by 27.94, and I get sine of O is equal to 0.7714. This is where I'm going to take that inverse sine of both sides, sine inverse of both sides. And when I do that, I'm going to get that angle O is equal to 50.48 degrees. So we get O is 50.48 degrees. And to find angle S, the easiest part of this entire problem, angle S is going to be very easy to find. We have to do 180, and we're just going to subtract 25, which will give me 155, but I need to subtract what we just found, subtract 50.48, and I'm left with that angle S is 104.52 degrees. That's just by triangle sum theorem. So that's number 5. Number 6, we have now side, side, side. So you have a couple options. First thing I would say is to look at it with the alternate formula. So we're going to say that cosine of an angle is equal to something. What angle do we want to find? The smallest one, the smallest side is T. That means the smallest angle will be big T. So that's what we want to have on its own. We're going to have then the other one. So in this case, f squared plus k squared minus 2fk cosine. I'm sorry. Help if I even did it correctly. F squared plus k squared, now a minus t squared over 2fk. I was going a little bit too far and trying to set up this formula. If you prefer doing it with that formula, go ahead and do it that way and then solve for cosine of t that way. If you do, you would get this one. I'll show you that way in a minute. We'll start here the way we got it with the blue. So now I'm just going to plug and chug from here. F is going to be 14 squared, 18 squared, minus 11 squared, over 2 times 14 times 18. That means that cosine of t is equal to 0.7917. The inverse cosine of both sides means that t is equal to 37.66 degrees. 37.66 degrees. Now again, I said you could go with this equation that has the cosine t, the alternate form, or we could have done this the exact same way and gotten the exact same answer by plugging into the original formula and solving for cosine t. Either way works. Alright, now again, I now have a angle side pair that I can use, so now I can just use law of sines again. So I'm going to say sine of 37.66 over 11 is equal to sine of, I'm going to find f first because f is the smaller of the two than angle k. So sine of f over 14. Cross multiply and divide, I'm going to get that sine of f will equal, it's 14 times sine of 37.66, and that's going to be divided by 11. When I do that, it means sine of f is 0.7776, where angle f, when I take the inverse, is 51.04 degrees. So angle f is 51.04 degrees. And then again, I get angle k just by doing the 180 minus f minus t, so k is 91.30 degrees. Push forward to number 7, triangle USA here. Okay, we have another side angle side, so we definitely want to use our original formula, and we want to find the side opposite the angle. So s squared will equal u squared plus a squared minus 2ua cosine of big S. Plug and chug. Side u is 13, side a is 28, minus 2 times 13 times 28 times cosine of 71 degrees. When I plug all that in, I should get that s squared is equal to 715.99, which means that s will equal 26.76. Okay, so s is 26.76. Same thing, now we have our angle side relationship pair. I can now set up the law of sines. Sine 71 over 26.76 is going to equal, again, we got to look at the smaller one, so we got to do sine u right now. So sine of u over little u, which is 13. Cross multiply. 13 sine 71 equals 26.76 sine of u. It means that sine of u, when I divide, will be 0.4593. And that means that angle u is going to be 27.34 degrees. 27.34 degrees. And that means that in the end again, to find the last angle, I'm just going to add them up, and I should get 81.66 degrees for my final angle there. Alright? 2 more. Number 8, triangle LAW. Now, pay attention, I'm going to try to trick you. This one is an angle side angle. Angle side angle does not work for law of cosine, but it does work for the law of sine. So we're going to do the law of sine right from the beginning for this one. So what I can find here, I have 2 of the angles. That means I can find the third immediately. It's 80 degrees because they add up to 180 in total. So now I have my relationship here. So now I can set up my law of sines. I'm going to have sine of 80 over 50 will equal sine of 22 over A. And then I'll also have sine of 80 over 50 will equal sine of 78 over W in that case. Okay? When I cross multiply and divide, I should get A equals sine of 22, 50 times sine of 22, over sine of 80, which will equal 19.02. And then I will also do the same for side W and get W equals 50 sine of 78 over sine of 80. And W then will be, as a result, 49.66 for that answer. 49.66. Alright, and one more to go. Triangle TRG. Alright, I'm going to set this up. I want to find the smallest angle first, which will be angle G. So that's what I'll set up first and say that I'll use the cosine G alternate formula. So that'll be then the other two, T squared plus R squared, then I minus G squared, over 2TR. That means cosine of G is equal to, T is 22, R is 41, G is 14, over 2 times 22 times 41. That means cosine of G, when you do that division, will be 1.09. So next I would take the cosine inverse of both sides, which you cannot do because cosine cannot be above 1. So that means that this triangle does not exist. And like I said before, we actually could tell that right from the beginning because the two smaller ones, the two smaller sides, 14 plus 22, that only equals 36. That's not as big as the third side, as the biggest side. Not big enough. So I could have said right from the beginning here, seeing that no, this triangle does not exist in this problem. So there you have it. You can check the other videos to do the application problems to make sure we can get all those right. But if you can do this, then you'll be perfectly ready for your quiz.